Welcome back. In this lesson, we'll be covering the testing protocol for factorial designs, where we're going to be talking about how do we step through once we have the ANOVA table, and we're going to be introducing new terminologies like separation and masking. We'll be doing this through the pesticide example. So let's start with what the suggested protocol for factorial designs is. Typically, you want to start with the highest order interactions. So in a three-way factorial design, that's going to be the three-way interaction. In a two-way factorial design, that is a two-way interaction. And so if the higher order terms are not significant, let me define what I mean here. By higher order, I'm talking about your three-way interaction. So that's your alpha, beta, gamma term. In your two-way, that could be your alpha, beta, alpha, gamma, or gamma, beta terms. What I mean by not significant, that is your p-value is less than your significance level. So if this is true, then you can proceed to testing your lower effects and so on. If your higher order terms are significant, then this is where things get a little bit harder and we have to start exploring our data. What I mean by exploring our data is we have to start looking at plots, very specifically our interaction plots, and we have to start thinking about what our data is, what is our problem, in order to help us decide if we can get down to looking at the lower levels, i.e. the two-way interaction or even the main effects. We only test on the main effects that are not involved in any significant interaction. So let's talk about how we can do our exploratory. So a lot of this lesson is going to be focused on exploring the data through our two-way interactions to help us. How do we look through our two-way interactions? It's similar to the RCBD where we started to look at block treatment interactions, but now what we're going to be looking at is treatment interactions. And so if A and B interaction is significant, we can look at their estimated cell means to see what's going on. Even if they're not significant, you can look at the interactions. If the interaction isn't significant, you'll see parallel lines, most likely. So again, we're only going to test the main effects that are not involved in significant interactions. So the majority of this lesson is going to be focused on when the factors are significant or the interactions are significant. And so how do we deal with these situations and how do we do the inference? So again, back in the GRCBD, we talked about block treatment interactions and when they were significant, and we had codirectional interaction and anti-directional interaction. Codirectional was the interaction plot showed similar, not the same, trends, and we were able to then also go look at the treatment effects for our alphas. But if we had anti-directional interaction showing our interaction plot showed difference trends, then we weren't able to go look at those treatment effects. Now we are going to have another term, two different terms called masking and separation. Masking and separation is when our interaction terms are significant, but masking is when the main effects are not significant, and separation is when the main effects are significant. Okay, so in these two examples, we can see that we have interaction. Here's our interaction plots. An interaction says that if the effect of one factor changes for each level of the other factor. So specifically, if the effect of factor C changes for each level of B. So here, in this case, we're in the effect of factor C is changing and going decreasing for this treatment B1 to B2, or for this treatment, B2's here. For B2, we see that it's increasing. And so this shows we have an interaction. Here, we can see that this is going down and this is increasing. So again, there's a difference. So the effect of what's going on from factor C1 to C2 in B1 and B2 are different. So in order for us to tell someone what's going on from C1 to C2, we also have to tell them what's going on with B1 and B2. As an aside, we can look at our main effect for C. How we got this plot was averaging this blue dot and this red diamond to get this triangle. These two here, these two here, here. And this is showing us that there would be no treatment effect for our C. Here we can see that there probably might be a slight main effect for our C. So these are just the main effects for C. Let's go into some more examples to help us understand this a little bit further. So example 1 is these two where we have treatment A with levels 1 and 2 and treatment B with levels 1 and 2. And then here it's just having treatment B on the X and A as the trace factor. In this example, we have no interaction. So there's no co-directional, no anti-directional, no separation, no masking, because there is no interaction. These lines are parallel, so both the tests on the main effects will be meaningful. In this example, we have interaction, but no masking. So both the tests of the main effects are meaningful. So if we were to look at the main effects for A, that is average over factor B, we'd see a similar trend in the interaction plot that we do for the main effect. So let's just draw the main effect here. A1, A2. We're going to average, and we would say it's probably going to look something like this with our line. This point just came from averaging. And this trend matches roughly what we're seeing here. If we were to draw the main effects, ME of A, the main effect of B, B1, B2, we'd probably see something like that. Not exact, but hopefully you guys get the idea. I'd probably draw a line right there. It's the average. So in this case, by looking at the main effect and the interaction, main effect and the interaction, we're going to see that there's no masking. The ANOVA table here might tell us that the interaction of AB and the main effects are significant, i.e. the p-value is less than our alpha or our significance. And from our main effects of B, we would say that B increases, which is true. I mean, we can see that it increases here. It looks like it's increasing, even though maybe the picture doesn't look exactly like it. But A looks like it's increasing more than A2. For our main effects of A, we would say that A is decreasing, which is true. For both, you can see they're kind of decreasing, but B2 doesn't decrease as much as B1. So the caution here that I'm trying to hopefully make is that the main effects of A and B may be significant, but the effects are significant for A and B, but the effects at different levels might not be significant. And this is similar to what we talked about in the GRCBD, where we might say that there's an interaction, but within B1 and B2, they're different. And so you want to be careful with that. And that's what this statement right here is trying to tell us, is that it's telling us what's going on with the interaction, but it's also telling us the impact of the interaction. So if we look at A and B by themselves, we might not get to the same conclusion as if we looked at them individually in the groups. Okay, now let's move to another example where we have interaction, but B is going to be masking. You can't see what I'm talking about. Okay. This caution was for the previous plot that was right up here. Again, pretty much saying that A and B are significant, but the effects of B within the levels may not be significant. In this example, we're going to go to a different example where we're going to have interaction and B is going to mask A. So it's going to imply that we can test on the main effect of A, but we shouldn't be testing on the main effect of B. How we can look at this and help get an idea of whether certain main effects are being masked by the other is through looking at the main effects. So if we looked at the main effects of A, we're going to have A1, A2, and then again, roughly, we'll have a trend that looks something like that. And I would say that this overall trend here in the main effects would match the overall trend of the main effects would match the overall trend here. Now, let's say we went over and did the same thing and we looked at the main effects plot of B, B1, B2, and we averaged. It would probably look something like that. And I wouldn't say that the trend here of the main effects of B would match the trend in this interaction plot. And so this is going to help us determine that B is masked by our A. So what we did was that we looked at the main effects of what was on the X and tried to see if the trends would match. If the trends match, there wouldn't be really, we wouldn't define that as masking. But if the trends don't match, such as this one, then B is masked by our other factor, A. Now, we could test the main effect of A and get a meaningful, but we wouldn't want to test B. The ANOVA table would probably read as the interaction is significant for main effect A. So the ANOVA test would probably read the interaction is significant and the main effect of A is significant, but the main effect of B is insignificant. This doesn't mean that B isn't important. It means that B is highly wrapped up in A. So if you want to make a conclusion about B, you'd also have to include A. But we could make a general overall conclusion about A. Okay. Now, if we go to our next example, we have interaction and both factors are masked. And so we wouldn't want to test either main effect individually. So how we do this again is let's draw our main effects of A, because A is on the axis, A1, A2. If we were to average these two, we'd probably get a line here. Then if we were to do the main effect of B, looking on the x-axis, again, we'd have a straight line. which doesn't match the trend depicted in the interaction plot. So the ANOVA table here would probably read the interaction's significant, but the main effects are insignificant. Again, this doesn't mean that A and B are not important. It just means that the two factors are highly wrapped up in the interaction, and any conclusion you make on A or any conclusion you make on B requires that you have the other factor in there. So if I want to make a conclusion about A, I have to mention B. And if I want to make a conclusion about B, I have to have A. So when the main effects are insignificant, one meaningful analysis that you could use is contrast to test the main effects of one factor at a fixed level of another. And so there is some inference you can do, but it has to be done within the interaction term. All right. With that, let's now move to our pesticide example, which we talked about in lesson 7A. So in this example, we had two factors. We had our pesticide that had 4 levels, and we had a variety that had 3. Our first step was to do the ANOVA, and we'll go through this entire example in our next lesson, but I just want to talk about the interaction plots and how we would go about that. So here's one two-way interaction, here's the other. The difference between these two plots is we have variety on the X, and our pesticide is our trace factor, so it's the color. However, on this picture, we have our pesticide on our X and our variety on our trace factor. Okay. In our next lesson from our ANOVA table, we will see that there is no significant interaction. So next lesson, ANOVA is going to tell us there's no interaction here. And so testing both the main effects would be meaningful. But for the sake of this lesson, let's assume there is a significant interaction. Okay, so again, in our next lesson, I will show you guys that there is, according to our ANOVA table, there's no interaction, and you could probably get that from these, but let's just assume for this lesson that there is a significant interaction so we can have a little bit longer discussion. If we assume that there's an interaction, we're going to look at our two-way interaction. We can see that maybe this is codirectional because they're moving in the same direction pattern. Same here, same direction and pattern. The other thing we want to look at is our main effects plots, which are right here as well. Let me see if I can get both these pictures. Okay. And our question now would be, do we see masking or not? Okay, how we would look at masking again is looking at our main effects. Here's pesticide is on the X here, so this would actually go with this one. This is variety, that would go with here. And I would say that this trend matches pretty well with that trend. And this trend matches pretty well with this trend. Maybe our pesticide 4 is a little bit different. But overall, these main effects match this. So my conclusion, if we're assuming that there's a significant interaction, would be that it's codirectional, but there's no masking. Typically, with masking, a good way to think of it or see it would be in the ANOVA table, because we would see that the interaction is significant, and then one or both of the main effects are insignificant, which was talked about previously. So overall, the testing protocol is test your highest ordered effects and work your way down. In some analysis, we may not even be able to make a conclusion about our main effects because the interactions are so involved. In our next lesson, we're going to provide examples. We're going to go all the way through this pesticide example. We're also going to go through the bologna example using our software.